Good morning everyone. In the previous class, we have finished first concept of GOC, General Organic Chemistry, Introduction, how we can find bond length and hybridization. Let us discuss some objective questions on concept 1, Introduction, right? Let us discuss GOC worksheet 1. Question number 1. Urea was prepared first time in the laboratory by heating. Already we discussed in the introduction part. This is the first organic compound prepared in laboratory by heating ammonium cyanate. If you see the options, option 1 ammonium cyanate, second one ammonium cyanide, third one ammonium isocyanate and ammonium isocyanide. All the options, if you observe, all the options looks like they are confusing way, right? But what is the right answer for this one? Ammonium cyanate. Ammonium cyanate. What is the formula of ammonium cyanate? NH4 CNO. Ammonium cyanate. On heating, it undergo rearrangement and gives urea. What is the formula of urea? NH2 CO NH2 urea. This is the first organic compound prepared in laboratory by heating ammonium cyanate. Ammonium cyanate, right? So then the correct answer is first option, right? What is alicyclic compound? Cyclic means the first carbon and last carbons are connected. That means forms a ring. Cyclic compound means, for example, like this. It's a cyclic compound, right? And alicyclic compounds. Alicyclic compounds means properties resemble with aliphatic compounds, but they are cyclic. That's why they are called as alicyclic compounds. If you go with option 2, hexene. Hexene, it's an aliphatic compound, right? First carbon and last carbons are not connected. It's like a chain. Hexane. Hexane also aliphatic compound. Pyrrole. If you go with pyrrole, what is the structure of pyrrole? It's the pyrrole. Pyrrole. It's an aromatic compound, not aliphatic compound. It's an aromatic compound. Now, option 1, cyclohexane. This is cyclohexane, right? Cyclohexane. Properties resemble with aliphatic compounds. That's why this is also called alicyclic. This is cyclic and the properties resemble with aliphatic. That's why this is also called as alicyclic compound. So the right answer is cyclohexane, right? Next question. List A. List A molecule given, and list B pure and hybrid orbitals. The correct match is orbitals involved. Number of pure orbitals and number of hybrid orbitals in the given molecule. Now we have to identify which one is the correct match, right? First one, C2H6, ethane. What is the formula of ethane? C2H6, right? What is the structure of C2H6? The structure of C2H6. What is the hybridization of carbon in C2H6? This is sp3 hybridized, right? Why? Because around the carbon 4 bonds are there, 4 sigma bonds. Around the carbon 4 sigma bonds sp3 hybridization, 3 sigma bonds sp2 hybridization, 2 sigma bonds sp hybridization, right? This carbon also sp3 hybridization. Carbon undergo sp3 hybridization means hybrid orbitals 4, pure orbitals 0, right? 2 carbons, both the carbons sp3 hybridized. Total hybrid orbitals 8, because 2 4s are 8. Pure orbitals, carbon pure orbitals 0, because already sp3 hybridized. Hydrogen also pure orbital, right? Because this is also not hybridized. So hydrogen also pure orbital. How many hydrogens are there? 6 hydrogens are there, 6 pure orbital. So finally hybrid orbitals 8, pure orbitals 6. Hybrid orbitals 8, pure orbital 6. Pure orbital 6, hybrid orbitals 8. So A match with 4, A4. Then we can eliminate option 2 and option 3 easily because A match with 4 only, right? So maybe option 1 and option 4 alive, right? Next one, C2H4. What is the structure of C2H4? CH2 double bond CH2, right? Around the carbon, how many sigma bonds? 3 sigma bonds. 1, 2, 3. 3 sigma bonds. So sp2 hybridized. This one also 3 sigma bonds. sp2 hybridized, right? sp2 hybridized means how many hybrid orbitals? 3 hybrid orbitals and 1 pure orbital. Each carbon sp2 hybridized means 3 hybrid orbitals and 1 pure orbital. So 3 hybrid orbitals plus 3 hybrid orbitals, overall 6 hybrid orbitals. Pure orbitals, here 1 pure orbital, here 1 pure orbital, total 2 pure orbitals, and also each hydrogen also not undergo hybridization. That's why each hydrogen 1 pure orbital. Total 4 hydrogens, 4 pure orbitals. So 2 plus 4, 6. So finally pure orbital 6 and hybrid orbitals 6. So then this one, B match with 3. So then B2, B3. So option 1 also eliminate. So finally what is the right answer? There is a chance for fourth option. Let us check C and D also. From A and B we can identify option 4. No need to check again because we can eliminate 2 and 3 by discussing option first question. By discussing A, C2H6 we can eliminate second and third option. By discussing C2H4 we can eliminate option 1. So only one option still alive, that is fourth option. Maybe this is the right answer. Let us discuss C and D also. C2H2 acetylene. What is the formula structure of C2H2? This is the structure of C2H2, right? Around the carbon 2 sigma bonds. That's why sp hybridization. Here also 2 sigma bonds, sp hybridization. If carbon undergo sp hybridization means how many hybrid orbitals are there? 2 hybrid orbitals and 2 pure orbitals are there. So 2 carbons, each carbon 2 hybrid orbitals, total hybrid orbitals 2, here hybrid orbitals 2, total hybrid orbitals 4. 4 hybrid orbitals. Pure orbitals, at each carbon 2 pure orbitals, 2 carbons, 2 twos are 4, pure orbitals 4. Hydrogen also pure orbital, right? 2 hydrogens, 2 pure orbital, so then 2. So pure orbital 6, hybrid orbitals 4. Pure orbital 6, hybrid orbitals 4. So C match 2. C 2. And finally D, benzene. C6H6. Benzene structure, you know, the structure of benzene, right? C6H6. Each carbon sp2 hybridized, total 6 carbons, 6 hydrogens. Each carbon sp2 hybridized, right? Why? Because around the carbon 3 sigma bonds, 1, 2, 3, 3 sigma bonds. Each carbon sp2 hybridized. So each sp3 hybridization, 3 hybrid orbitals. So that's why 6 3s are 18 hybrid orbitals. 18 hybrid orbitals. And pure orbitals, each sp2 carbon 1 pure orbital. So 6 carbon atoms, 6 pure orbital plus 6 hydrogens. 6 hydrogens. So finally overall 12 pure orbitals, 18 hybrid orbitals. 12 pure orbitals, 18 hybrid orbitals, and the correct choice is fourth option, right? See the next question, assertion reason type question. For this one, first option, both A and R are true and R is the correct explanation of A. మనకి 2 statements ఉంటాయి, one is assertion, another one is reason. In case both assertion and reason are true and the reason is the correct explanation of assertion, then your choice is first option. Second one, both assertion and reason are correct, but reason is the not correct explanation of assertion, then your choice is 2. Third one, assertion is true, but R is false. Fourth one, A is false, but R is true. A is false, R is true, right? These are the 4 options. Let us discuss. See this question. Carbon-carbon bond energy values in the order of C2H2, C2H4, C2H6. You know, C2H2, it's an alkyne, right? Alkyne, there is a triple bond between carbon and carbon, C2H2. C2H4, it's an alkene, ethene, right? This one ethine, alkyne, ethene or ethylene, double bond between 2 carbon atoms. Ethane, it's an alkane, single bond between carbon and carbon. You know, bond energy directly proportional to number of bonds between carbon atoms. More the number of bonds between 2 carbon atoms, more bond energy, bond strength more. Here triple bond, double bond, single bond. You know, bond energy order, carbon-carbon triple bond greater than carbon-carbon double bond greater than carbon-carbon single bond, right? Bond energy increases with increasing in the bond order, right? Yes, correct only. Here what is the bond order? 3. Bond order means number of bonds between the 2 atoms. Here carbon-carbon bonds, how many bonds between 2 carbon atoms? 3. So bond order 3. Here bond order 2. Here bond order 1. More is the bond order. That means more number of bonds between the atoms. More is the bond strength. Bond energy high. So reason also correct. And reason is the correct explanation of assertion. Hence, what is the right choice? First option. Assertion and reason correct. And reason is the correct explanation of A. C bond H bond length in acetylene is 1.06 angstrom units and that ethylene is 1.09 angstrom units. C bonds H bond length in acetylene 1.06 and that in ethylene is 1.09 angstrom units. The lower the C bond H bond length in acetylene is due to SPS overlapping, right? In ethine, acetylene, nothing but ethine, right? Ethine. This is the structure of ethine, right? Acetylene. Here carbon, sp hybridized. In ethylene, the carbon is sp2 hybridized. This is sp2 hybridized. sp hybridized carbon, sp2 hybridized carbon. sp hybrid orbital are more size or sp2 hybrid orbital more size? sp2 hybrid orbital more size comparatively sp hybrid orbital, right? So that's why here there is a little more bond length comparatively here. Here bond length 1.06 angstrom units, here bond length 1.09. In ethylene, C bond H bond length more comparatively. C bond H bond length in ethine. Reason, in ethine carbon sp hybridized. In ethylene carbon sp2 hybridized. Comparatively sp hybridized carbon, sp2 hybridized carbon more size. sp2 hybrid orbital more size. That's why here bond length slightly higher comparatively here. So then assertion correct, reason also correct. Reason also correct, right? Then reason is the correct explanation of assertion. Okay, then what is the right answer? Option 1. See this question. The C bond C, this one C bond, C bond C bond length in benzene is intermediate between C bond C bond length and C bond C, C double bond C double bond length. In benzene, the C bond C bond length intermediate between C single bond C bond length and also C double bond C bond length. Benzene molecule exhibit resonance. What is the structure of benzene? Right? Here, two types of C bond C. For suppose if you go with this C bond C, right? This C bond C. Let this one bond length say X angstrom units. And here, this one double bond, C double bond C. Let's say this is Y angstrom units. X angstrom units, Y angstrom units. Right? Actually, C bond C single bond more bond length than C bond C double bond, right? Then we are expecting X greater than Y. X greater than Y. X greater than Y. We are expecting X greater than Y. Why? Because here carbon carbon single bond, here carbon carbon double bond, right? Generally single bond length more comparatively double bond, but practically both are equal. X equal to Y. All bond lengths are equal in benzene. All bond lengths are equal in benzene. What is the reason behind of this concept? Benzene exists in two resonating structures. That resonance concept you will learn in the next part of GOC. Just now you can try to understand. I will explain. Resonance structure means only change in the arrangement of pi electrons. Here double bond between these two carbon atoms, right? Now double bond between these two carbon atoms. Double bond between these two carbon atoms, here double bond. Double bond to these two carbon atoms, here double bond. So these are the resonating structures. Because of that resonance, each carbon-carbon bond length in between single bond and double bond length. No one is pure single bond carbon bond length and no one is double bond C carbon bond length. All bond lengths are equal. We have to say here benzene having partial double bond character, partial double bond character. All are partial double bond character. No pure single bond and no pure double bond. Partial double bond character. That's why in benzene all bond lengths are equal in benzene, right? So the C bond C bond length in benzene is intermediate between C bond C single bond length and C double bond C double bond length. Because of benzene molecule exhibits resonance. This is the correct reason for assertion, right? Hence the right chance is first option. Clear? See this question. Among the following compounds, which does not have more than one type of hybridization? Does not have more than one type of hybridization, right? If you go with option 1, around this carbon atoms 4 sigma bonds, right? Each hydrogen 1 sigma bond, here 1 sigma bond. So around this carbon atom 4 sigma bonds. So that's why this one sp3, this one also sp3. In first one, all carbons are sp3. All carbons are sp3 hybridized. All carbons. Second one, this carbon sp3 hybridized because of around the carbon 4 sigma bonds. But this carbon atom sp2 hybridized. sp2. Two different hybridized carbon atoms in this, right? Here, this carbon, sp hybridized because around this carbon atom, 2 sigma bonds only. This one in triple bond, 1 sigma bond and 2 pi bonds, right? So 1 sigma bond, hydrogen also 1 sigma bond, 2 sigma bonds, so sp. This carbon also sp. Here, this carbon sp2, 1 plus 1 plus 1, 3 sigma bonds, sp2 hybridized, and this carbon also sp2 hybridized. So here also 2 different hybridized carbon atoms, sp and also what? sp2. Fourth one, this carbon sp hybridized, right? This carbon also sp hybridized. This carbon sp3 hybridized. This one also 2 different hybridized carbon atoms. What is the question? Among the following compounds which does not have more than one type of hybridization. Hence, option 1 is the correct, because in option 1 all the carbons are sp3 hybridized, but in option 2 sp2 sp3, option 3 sp2 sp, option 4 sp and sp3 hybridized. Different carbon atoms are there, different hybridized carbon atoms are there, but the question is does not have more than one type of hybridization. So option 1. Got it? Next one. Number of sigma bonds in ethane formed by the overlap of sp3 and s orbitals. Ethane. What is the formula of ethane? C2H6, right? And the structure of ethane. This is the structure of ethane, right? Ethane. In ethane, the carbon sp3 hybridized, sp3. Hydrogen s orbital, right? What type of bond this is? Sigma sp3s, 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 sp3s. How many sp3s overlapping sigma bonds? 6. And this is what type of sigma bond? sp sigma sp3 sp3. This one sp3 sp3, right? sp3 sp3, because this carbon sp3, this carbon also sp3, sp3 sp3 hybridization, but these are sp3s hybridization. Total how many sp3s orbitals overlapping sigma bonds? Total 6. C bond H, each C bond H is sp3s hybridized, I mean each C bond H is sp3s overlapping, right?